I wouldn't put it there.
It's a risk I'm gonna have to take.
I wouldn't put it there.
Why not?
What if I step on it?
Well, I think it's a risk we'll have to take.
Factor, factor. Factoring never goes away in this class. So if you didn't learn to factor in chapter 4, this is what I was trying to tell you. Later in the year, this is later, you're in trouble. So you have to quickly figure this factoring out. I have more factoring next week. More new factoring. You have to learn this stuff. Elizabeth, did you factor this? No? Molly, did you factor this?
First one?
Yep.
Yes.
What'd you get?
I
Or what'd you
took-
do, I should say?
I took the GCF.
Okay, which is
X,
X. She took out an X. Good.
and I got X squared minus X minus 12.
Okay.
And then I factored that into X, parentheses X minus 4, and then X plus 3.
Okay. All right. Good. She did this. Let me just recap. She took out the GCF X, got this. She didn't say this, but I know she did it. She checked to see if this was her best friend. 12 is not a perfect square, so it's not a perfect trinomial. Wasn't her best friend, but then she looked in front and saw 1 and thought, this is an easy one. This is your friend. This is a good one, not your enemy. Factors of negative 12 that add up to negative 1. Well, this and this work. This is it. She got it. Okay? Letter B. Gavin, what'd you do?
I took the greatest common factor,
Which is
2x.
2x. So he takes out a 2x. Gets what?
X squared minus 49.
Okay. Then what, Gavin?
Then I put down my 2x.
Okay, 2x again.
Then I did x plus 7 and x minus 7.
Okay. Gotcha. Now, did you recognize x squared minus 49 as your best friend? Who's your best friend? The difference of two perfect squares. Hey guys, remember I said your two best friends will be the difference of two perfect squares right here, because you can factor it so quick, and a perfect square trinomial. Those are your best friends. You can factor them like this. The other ones, they take time. Okay, all good? Okay, I didn't surprise you. I just asked you to factor. You can take polynomials and you can factor them. That's what we did. Now, would you please do this now? Everybody, write this. Oh, I don't have much room. Would you please put equals 0, equals 0. Okay, put equals 0. Now I just made this polynomial a polynomial equation. Because I put what?
0.
Okay, put an equal sign. Equals 0. Now that I did that, can you guys tell me the answers, the solutions? Isaac, what do you got?
X equals 4.
X equals what?
X equals 4.
Okay, that's one of them.
And x equals negative 3.
Okay,
And x is 0.
and how about that one? Anything?
X equals 0.
Yes. Okay, x equals 0, x equals 4, x equals negative 3. These are what? What do we call these? Solutions. There's another name for them.
Answers,
How'd you know that?
because it's right there.
Oh,
Well, I didn't read it. I just there's zeros underneath that, so like.
we're supposed to be reading that. There are more names for this. They are solutions. He got roots because he read this. What did you say back there?
Answers.
Answers, yep.
Points on a graph.
Oh, what?
Points on a graph.
Points on the graph. Okay, yes, you're right. Okay, you guys
X
are,
intercepts.
you're the only class that didn't say what I wanted you to say. Remember back in chapter 4 when we graphed parabolas? We call these points the zeros. These were the zeros of your function. It says right here. Guys, look. Come on, look at this. When will it equal 0? When x is 0, when x is 4, when x is negative 3. These are called the zeros of your function. You guys should all go over there in the corner and draw this picture. You ready? Go over there and draw this. You know that these three numbers are called solutions, but they're also called zeros. What were they again? Wasn't 0 one of them?
4,
0,
and
negative 3, and 4.
Negative 3 and 4, right? Okay, so here's what really happens when you factor a polynomial, you're finding solutions. But solutions are really just what? Zeros. These are just zeros. Okay? Or you could call them solutions, because they're all solutions to that equation. Okay? Then Taylor goes and reads the paragraph below,
I didn't read
and he learns that they're also called this, roots. These are also called roots. Okay, and there's one more thing we can call them.
it.
X-intercepts. Look, these are just points on the x-axis. These are called x-intercepts also. Okay, now, this is really strange. When you guys when you solve that equation, you were finding 4 words. The 4 words are solutions, zeros, roots, and x-intercepts. These 4 words all mean the same thing, and you gotta know that from now till the day you die. Exactly. You can't forget that. So if I say find the solutions, I'm really telling you to find the what?
X-intercept.
X-intercepts, or the zeros, or the roots. Now, why is this so important to you? Because you're going to graph polynomials. And if you graph polynomials, you have to understand your answers are just the what?
X-intercepts.
So didn't I just find how many points on my graph?
3.
3. Now, here's what you can do now. You guys know about end behavior, right?
Yes.
End behavior, typically up, down, 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 up, or up, down. If I went like this, let's just pretend this one goes down on the left, up on the right. Well, once you know that, you should know, follow the pattern. Here I go. What's it going to do at that point?
Turn.
It's got to go from here to there, so it's got to do what right now?
Turn.
No, it's not going to go that way because I said they're not sharp.
Go up.
It's going to go up for a while, then what?
Down.
Then it'll come down, hit it. It's got to get over there.
You're going to go down.
It's got to go down through it and up. Look what happened. I already know this is just a quick what? A quick sketch. If you, yes, sir.
What happens if the both sides of the endpoints, what if they're both horizontal? So that's just not.
I get what you're saying. The end points
So you know how it goes down, up, or it just goes left and right?
never does.
So there we go.
Never does. Polynomials do this. They go like this for a while, and then after they do this, and at one point they go down forever, or up forever, or down, or up. You know, they go always like that. Okay. Here's the deal. What you don't know, this is the only thing you don't know. How high? How high should I go? That's what you don't know. I could have done this, right?
Yeah.
Or I could have went like that, right?
Mm-hmm.
So guess what your job is today? Find the peak, or find the what?
Valley.
The valley. Find your peaks and find your valleys. Okay? That's your job. All right. Okay. Did you draw this in the upper right corner?
Yeah.
Because this is important that you know those 4 words. Okay? All right. Here we go. This down here is just telling you what I just told you. So let's just do it quick. Would you do me a favor and do this? Cross out that bullet and write the word if. Just write it. Okay? Now let's read it. If x minus b is a linear factor of the polynomial p of x. Wait a second. Let's get rid of the b. Let's say x minus
7.
7, okay. Now let's do this again. If x minus 7 is a factor of the polynomial, then these next 3 bullets are true. Then 7 is a what?
Is a 0.
Is a 0. Then 7 is a what? Root. Then 7 is a what? X-intercept. There you go. Now guys, I just do the 7, who cares? It could have been 5, it could have been 2, whatever. All they're trying to tell you is, if you have a factor, x minus 7, then you should know 7 is a 0, 7 is a root, 7 is an x-intercept. Okay? These words are interchangeable. Probably the most important word up here to me, since you're graphing, is this word, since you're graphing. See that? Let's graph it. Is this in factored form?
Yeah.
They factored it for you. So this is a nice problem. Okay, finding the zeros of your polynomial function. Find the zeros of each function. Then graph it. Okay, well, let's do it. What are the zeros? Well, if they say that, let's just put a 0 there. When will that side equal 0? When this x is what?
0.
When this x is what?
Positive 3.
And?
Negative 5.
Negative 5. Okay, that was easy. And then you should know this. Not only are these called the zeros, better yet, they're called what?
X-intercepts.
X-intercepts. Okay, get over there, graph it. 0, 3, and negative 5. About there. Okay. Good? Okay. Polynomials, they just go like this. All the time. Okay, here's the deal. You should know. It's got to hit this point, this point, this point. It's got to do something like this. Or maybe this. Okay? But here's the thing. You know about this word. These 2 words are end,
Behavior.
behavior. How does it behave in the end? Okay? Anybody want to try to take a shot? I know how it behaves. Tell the class.
Down, up.
Down, up. He says down, up. How come? He just guessed.
Because you'd have to simplify it, the equation, so you'd get x to the third.
Okay. Here's what. Everybody listen. If you take this x times this x minus 3 times this x plus 5, if you actually FOIL it out, you don't have to, by the way. Just think about it. What's x times x? X squared. But then you're eventually going to have to take it times another x, which will be what?
X cubed.
X cubed. But did you ever see a negative?
No.
Guess what? It's a positive leading coefficient. It's positive, and it's an odd polynomial. Odd polynomials act like what? Parabolas or lines?
Lines.
Lines. Now, which one is it? That's positive. So is it this line
Positive, yeah.
or is it this one?
First one.
First one.
Down on the left, up on the right. Taylor, it's your day. You're guessing well. Okay, so here's what I would do if I were you. Down on the left, up on the right. That's what I do right now. So here's what you know. It's down on the left side. It's right up on the right side. You know the x-intercepts. You just don't know the peaks and the valleys, right? How high should I go? Should I go this high?
We'll find out.
And then this high? Or should I go way down here? Or should I go way up here? What should I do?
Well, looks like we'll find out. I don't know.
You gotta plug in.
You gotta plug in. Colton says you gotta plug in a number. Okay, so here I go. You do not have to make a lot of points. Matter of fact, you have to make 2 points because you have a peak and a valley. Okay, look at the x's from 0 to 5, negative 5. What x would you like to try?
2.5.
Yeah, go to the center. Go to the center. Colton says negative 2.5. I would do that too. Okay? Then let's get this one. Dead center. 1.5, yep. Okay, now go put them into your polynomial function up here. Hang on, I'm catching up to you. So here's me doing your negative 2.5, negative 2.5 times negative 2.5, take away 3.
34.375.
Okay, you guys, you see what I did?
Yeah.
I stuck the negative 2.5 in for that x, that x, that x. And here's what I'm getting. I'm basically getting this number times this number times this number, right? That's all it is. Now you could just type this into your calculator, use your parentheses, it's gonna come out. What did you get?
34.375.
34 point what?
375.
Okay. All right. It's kind of up there. It's up there, 34, whatever. How about 1.5?
When we find out.
Put it in.
Will we get the story problems today?
No, we're not gonna make that part. So 1.5 and 1.5, that's gonna be this. And 1.5, that'd be 6.5. So more or less, when you plug in the 1.5, these are the three numbers you'll multiply, right?
Yeah.
And you'll get
Negative 14.625.
negative 14.625.
625.
Colton, what's wrong? Which one's wrong? Well, I'm putting negative 1.5, take away 3, negative 1.5. Negative 1.5, oh, I'm sorry, positive 1.5 plus 5 is 6.5. Okay? So that's what I'm doing in my head. Okay? Okay, guys, here's the only problem. My graph paper goes up 10 and down 10. How do I get to this number? Go by what? Yeah, we tried. Last period they kept going. Somebody told me to go by halves.
What?
And I went, "Oh, we're never gonna make it. Then they said twos, and I went, well, 2 will get you to 20. 4 will get you to 40. You could have went by 4s, but it's easy to count by what? It's easier to count by 5s.
Should we just say the y-intercept by 5?
Yeah, that's it. We're not changing the x. Don't change your x-axis. Okay, so there we go. Okay, here we go. 5, 10, 15, 20, 25, 30, 35, and I'm not quite at 35. There's 35. So to me, this graph goes like this, connect here. Then at 1.5, I go down how far? 14, about here. There it is. I got it. Now, do you know why you're going to get this wrong on the test?
It's extremely small numbers.
No, that's not it.
Because we're gonna forget to have the one right in the middle. The things are in
No, that's not why. You're gonna forget to tell me what.
You're gonna tell.
Oh,
we're
by
gonna
5.
forget how
You're
to-
not gonna say this. You're gonna in your head. You're gonna go. I'm calling by 5s, and he should know that. I don't know that because Taylor might go by 5s. Colton might go by 3s. Aaron might go by 4s. I don't know. And if you guys don't tell me, guess what I assume?
Go by ones.
You're going by 1s. And then I go, oh look, they went up 3 squares. They went up 3. And really, he's thinking
You went up
5, 10, 15. I'm up 15. I didn't know. So I'll give you some credit, but I can't give you all the credit. Gotta tell me what you're going by. Okay? All right, guys, we're not gonna do the next one, but we're gonna sketch it. Here we go. First things first, go get your zeros or your x-intercepts. We're not gonna do it. We're just gonna do a quick sketch. What are they?
X equals 3.
3.
X equals negative 4. And x equals 1.
Got it. Yes, they are your zeros because if you let y be 0, these are the zeros. But they're also called the what? x-intercepts, and roots, and zeros, and everything, okay? But most importantly, they're the x-intercepts. So 3, 0, no, 1, and -4. Got it. Talk about end behavior.
Go up, right?
Watch this. What's this times this?
X squared.
X times x is x squared times another x. It's really just x cubed
No minus.
with a 1 in front. It's odd, so it's a line going
Down up.
this way. Down up. So you could just do this right now. This, right?
Yeah.
And then you kind of know already what it looks like because it's got to go through this point, hit this point, go through it, and back up. What's the peak? What's the valley? Well, all I care about is you just set up a table. We're not going to really go find it unless you want to take time to do it. What would be good x values to try? What's dead center between 1 and -4?
-1.
2.5.
Negative.
Isn't
What?
it negative 2.5? Or negative, yeah.
What, 1, 2, 3.
-1.5.
1.5.
1.5. I'm hearing -2.5, but that's not the center.
No.
Oh, that's how far away from the middle it is.
Yeah. Okay. Yeah. The middle between 1 and -4 would be -1.5. What's the middle between here and here? 2. There you go. Question mark. Question mark. I don't know, and I don't really want to take up your time, but we do know this. It's gonna do that, right? Something like that.
Something like that.
That is just a quick sketch. That's not. That's a sketch. I don't really know if that's how high or low I'm supposed to go. Okay, move on. Next up, page 2. Okay, first of all, let's do this right away. That you can get rid of. Okay, just get rid of it. Okay. This one you can't get rid of. It's called the what theorem? Factor theorem. Now, here's the deal about the factor theorem. If you read it, it's kind of, it makes sense, but it's kind of confusing what they're trying to tell you. So I'm just going to read it to you, then I'll tell you what it says, but here's what it's saying. The expression x minus a. Let's not say x minus a. X minus what?
3.
3. Okay, just kind of do that for now. So the expression x minus 3 is a factor of your polynomial. If and only if the value of, the value what?
2.
3.
3, because you guys chose 3, is a what?
0.
If 3 is a 0, then x minus 3 is a factor. So what did they say? Here's what they said to you. If you're given, okay, if you're given a 0, 3,
Okay.
then if 0 is a 3, then where does 3 come from? It comes from a factor.
It would be x minus 3 then?
X minus 3.
It doesn't have
Okay, listen again. This is all they're saying to you. If your 0 of your polynomial is 3, then it came from that factor x minus 3, right? Okay, try this again. If your 0 is a negative 5, then it came from a factor. What factor?
5 minus 5.
x plus
5 plus 5.
x plus 5.
Yeah, here's what it's supposed to be, just so you know. It's always going to be x minus the 0. What's the 0?
-5.
-5. But that makes what?
Plus 5.
X plus 5 is your factor. So to me, when somebody tells me my 0 is 5, then the factor is x minus 5. If it's -5, then it's x plus 5. It's kind of the opposite of what they give you. Okay? That's all this factor theorem said. That's it. So if you continue, this is the next thing. It says write a polynomial function. This is what they want you to do. Give me a function, a polynomial function, in what form? Standard form, with the given what? Oh, they're gonna give me zeros, and they want me to write a polynomial? Okay, let's do it. Hey, one of my zeros happens to be 3, and the other one is?
-3.
-3. So how do I write this polynomial function?
X plus 3, x minus
Say that again.
3. X plus 3 and then x minus
Yeah, but you said it backwards.
3. Well, yeah.
So if your 0 is 3,
Then it'd be -3.
then it'd be x minus 3. If your other 0 is -3, then the factor would be what? X plus 3. So what happens is, when they give you zeros, they're actually giving you factors of your polynomial. Now you know what I did? I wrote a polynomial in what form? That's not standard. That's factored form. Okay, I almost have it. I just got to get it into standard. How?
Foil.
Foil, guys. This is so easy for you. Foil it out. You're done. Go. Go, go, go.
I think I got it.
Go, go, go. Some of you are still staring at the carpet. Carpet is never going to change. It stays the same color all the time. What was your polynomial in standard form? X squared minus 9 is the answer.
Okay.
Okay? Hey guys, you know what they did? They gave you the answers to your polynomial, which generate the factors of your polynomial, which means you can FOIL it out to get your polynomial. This would be like the starting point. It's weird. They went backwards. They gave you the answers, and they expect you to go back to the beginning. Okay? Notice, please notice, if you have 2 zeros, what kind of polynomial do we call this? Quadratic. If you have 3 zeros, what do you think you're going to get? Cubic. If you have 4 zeros, what do you think you're going to get? Quartic. Which one's the longest one? Quartic. This one, we're not going to do. This one, you're going to do it. Right now. Go.
I might have gotten it.
First factor, Eric, what is it?
X minus 1.
X minus 1. John Lewis, what is it? Second factor.
X plus 1.
X plus 1. Adrian, third factor.
X minus 4.
Got it. Good. Now, when you have 3 factors, you do have to FOIL, but you can't FOIL all 3 at once. You have to ignore one of them. Me, I would just pick the last one. I'd ignore it. I wouldn't even look at this. I just FOIL those 2. Get an answer, then FOIL x minus 4 later. Okay? So this one's going to take some time.
Oh, okay. No,
FOIL, FOIL, see what you get. Okay, I FOILed the first 2, I got x squared minus 1. Now, I bring down the x minus 4, and now what do? FOIL again, just FOIL again, see what happens.
Oh, no, I didn't. Oh, maybe it didn't.
When I FOILed, I got that, and are there any like terms?
X and, no.
No, x cubed is different than x squared is different than x, and x is different than 4. You're done. It's in what form? Standard form, you're done. Your polynomial function that had those zeros is right there. Okay? Okay, here's the deal. I don't want to do the next one, but I do want to get it set up with you. These are your zeros. What would your factors be? Here we go. P of x. Elizabeth, give me one factor.
X plus 1.
X plus 1. Faith, give me another one.
X plus 2.
X plus 2. Ethan, give me another one.
X plus, X plus 2.
Yeah, X plus, okay, good. Last one, Aaron. X minus 3, got it. Okay, so this is as far as I wanted to go with you, except for one thing. You see these factors that are identical? You could have shortened it up and said P of x equals what?
X plus 1
Times
X plus 2 squared.
x plus 2 squared times x minus 3. You could have shortened it up, which I want you to, by the way. And why do I want you to shorten it up? Because of this next little paragraph. And by the way, we just entered what?
Day 2.
Day 2. And I got 10 minutes. Here's the deal. Guys, if I can get through this next section with you, you'll be thankful. Because Monday will come and I can just say, remember at the end of Friday? And you'll go, oh yeah. All right. Now, ready? Keep this in mind. Look right here. Keep this in mind. Ready? In example 3C, which one was example 3C? This one. This one. Okay. In example 3C, the repeated linear factor x plus 2. This factor right here, x plus 2, makes negative 2a. Negative 2 would be called a what normally? Okay, I'll give you one answer. Solution. Negative 2 would be a solution. I don't want that. What is it?
0.
It's a 0. Negative 2 is a 0.
Okay.
But because of that 2 up there, it's now called a what kind of 0?
Multiple 0.
Multiple 0. It happened more than once. It actually happened how many times? Twice. Okay. Keep reading. In particular, since the linear factor x plus 2 appears twice, if it appears twice, you can say that negative 2 is a 0 of, and here it comes, here's the big word,
Multiplicity. Oh,
multiplicity 2. Negative 2 is a 0 of multiplicity 2. It happened twice, so we call it multiplicity 2. Okay? So guys, what if, just what if this would have been a 3? Multiplicity of 3. If it's a 4, multiplicity of 4. Get it?
Yeah.
Okay. Now, can you do me a favor? Don't read this. Don't read this until later. Later you can read it and see if it makes sense. But don't change page. Don't stay here. Stay here. Underneath, you have room?
Not much.
There's a little bit of room, not much. Okay, underneath, you want to write this. Okay, we are going to talk about multiplicity. Why do we need to talk about it? Why is it important? Because of this. There are 2 types of multiplicity. One is this, even. One is this, odd. Okay, you got 2 types, even, odd. And I will ask you when you guys are graphing, I'll say, hey guys, is that 0 a multiplicity even or odd? And you'll say, oh, that was odd, and that was even, that was even, that was odd. Okay, that's what you'll say. But what does it mean? Well, here's an odd. X plus 2 to the first. X plus 2 to the third. X plus 2 to the fifth, and so on, right? Those are odd multiplicities. These are evens. X plus 2 squared. X plus 2 fourth. X plus 2 sixth. I could keep going, but I'm not going to. All right. So why is it important? Watch. When you graph multiplicity of 2, 4, 6, 8, or 1, 3, 5, what happens on this one is, can you guys tell me the 0 out of that?
-2.
-2. Okay? Okay, here's what happens. When your multiplicity is odd, your graph of your polynomial will come down to it, and it actually goes through. It goes through the x-intercept.
Okay.
But if the multiplicity, let me put the M1. If the multiplicity becomes what? 3. It still goes through, but it goes through like this.
Okay.
A little what?
Weird.
Well, I like to say a little slower. This goes through quick. This one goes a little slower. I call it flat. A little flatter than the previous one. So this would be multiplicity of what?
3.
3. Any guesses what a 5 would be?
Even slower.
Even slower. Comes like this. Here's a 5. That's a 5. So the higher the multiplicity, the slower it goes through your x-intercept. You get that?
Yep.
Okay. So what's the difference between odd and even?
No clue.
Oh, guys, don't say no clue.
I don't have a clue.
Don't go faster. Wait, what if you just like
Okay, wait a minute. End behavior. What did end behavior mean if it was even? Acts like a what?
up or a
Parabola.
down, down?
Parabolas. What did odd mean?
It's not a parabola.
Acts like a line.
Yeah.
Hey, look. That's a line. Come on. Guess what it's going to do?
That'd be a parabola.
It's going to act like a parabola. So watch this. 2, multiplicity of 2 would look like this. Acts like a parabola. It bounces. It bounces. Okay? What do you think multiplicity of 4 is going to do?
Even slower.
Bounces,
Widen it.
but slower. Look. Okay? That's multiplicity of 4. And a multiplicity of 6 would bounce again, but what?
Slower.
Slower.
So, like,
Okay.
widen it.
So the bigger the multiplicity, the wider
Yes.
the bounce. Okay, the flatter the bounce on the bottom. Does that make sense?
Yeah.
Remember, this is recording and there's just a little bit. Okay, next up. Does that make sense or not?
Yeah.
At least, yeah.
None of this makes sense, but keep going.
Okay. So at least you and I get to hang out after school today,
Yeah,
right?
probably not.
Usually not.
Okay.
Party
All right, you ready? Here it comes. We're only going to do the first two. Ready? Find the zeros of each function and state the multiplicity of multiple zeros. Okay, here we go. I would like you to do this. Make a table for me. Give me the zeros and then give me the multiplicity of the zeros. Okay? All right, you ready? Look at that function. Tyler, can you give me the zeros?
0 and then -1.
Okay, 0 and -1 says Tyler. Is he right?
Yes.
Yes, he got the zeros right. Give me the multiplicity, Branson, of this number. How many times did 0 happen?
2.
2.
No, 1.
1.
I only see it once, and the reason I say once is because it says x to the first.
Yeah.
So I say 1. Now this one, this -1, I know it's a 0, but it happened twice. Because the exponent says what? 2. So now, you guys, I will talk about this on Monday, but if we happen to graph this one, okay, we would hit the x-axis at 0. Would we go through it or would we bounce? Look at the multiplicity.
No, we go through it.
We go through
It's
it.
odd multiplicity, go through. Then we would hit this x-intercept. And what would we do? We would bounce. We'll talk about this on Monday. Next, let's do this one. 0.
Hold on.
Multiplicity. Ready? Put my picture on now. Harry,
I'll tell you one.
give me a 0.
Oh, 0.
No. Adrian?
2.5 and
2.5 and 3. So he gives me both zeros. He's right. Adrian,
3. Yes, sir.
finish it.
Ooh.
This 0 has multiplicity of what?
No, 1. Would it be 1 and 3?
You sound like you're guessing.
I was, but.
Look at the
I was
exponent.
guessing in the beginning of the
Look at the
sentence, but I
exponent.
figured out what the
1.
1 and 3.
Yeah. Now,
Sweet.
Monday, wait, don't pack it up yet. Hang on. Monday when you come back, when we graph something like this, we would hit this on the x-axis. Would we go through or would we bounce?
Go through.
We go through. We would hit this. Would we go through or bounce? Through. We're going to do it fast or slow?
Slow.
Got it. Have a good weekend.
Oh.
You're lucky I didn't step behind your something You might want to grab pictures of the top shelf right there. Wait.
I have a little bit of raspberry jelly.
We have a
Every day.
3 o'clock date.
Great.
Okay,
There's no way that
Oh, yeah.
No. I didn't say that. I never said that. You just do.
Hi, Autumn. What?
I love these. So fun.
Polynomials are the best.
Yeah,
They're the best thing ever.
Your girl, whatever, I can't remember, Nicole.
Yeah.
No.
Nicole.
Okay. She didn't do very well. On that.
Yes.
Yeah. But that was to be expected.
Did she at least kind of have the process a little bit?
No, she didn't. I can look at it, but I don't think it was.
Oh, well.
Yeah.
She'll be fine.
Yeah, she will be as soon as we.
Grab notes, just like last time. It's 2 pages. They go in a row, so don't mess us up. 2.